Hello everyone, welcome to another kinetic tutoring video. Today we're going to be talking about angular velocity, acceleration, and position. This one's going to be a shorter, simpler video, so let's just get straight into it. The angular velocity of a 755 gram wheel, 15 centimeters in diameter, is given by the equation omega in terms of t is equal to 2 radians per second squared times t plus 1 radians per second to the fourth t cubed. And part A is asking us through how many radians does the wheel turn during the first 2 seconds of its motion. And part B is asking us what is the angular acceleration in radians per second squared of the wheel at the end of the first 2 seconds of its motion. Okay, so what I like to do first with these types of problems is to rewrite the equation without the terms, without the units rather. So we can just write omega in terms of t is equal to 2t. Since we have the 2 here, we don't have to write the radians per second squared, plus 1t cubed, which we're just going to write as t cubed. And we're looking for how many radians it turned. And we know that omega is simply the change in rotational distance over the change in time. So we can rewrite it as that. And our next step is going to be to multiply both sides by dt to separate the variables. And we get d theta is equal to 2t plus t cubed times dt. And our next step is to integrate both sides. The integral of d theta is just going to be theta, and the integral of 2t is t squared, and the integral of t cubed is going to be 1/4 t to the 4. And this is a definite integral going from t is 0 to t is 2. We know that t is equal to 0, the radians is going to be 0, and so we plug in 2 to our equation to get our radians. So we get 2 squared plus 1/4 2 to the power of 4. 2 squared is 4, and we have 1/4 times 2 to the 4, which is 16. 16 times 1/4 will give us 4, so 4 plus 4 is going to give us our radians, which is 8, meaning that the wheel has turned 8 radians in the first 2 seconds of its motion. And the units for this would just simply be radians. Alright, so let's move on to the second part of the problem, which is asking us what the angular acceleration is going to be of the wheel after the first 2 seconds. So let's rewrite our original equation. And in this case, we're going to want to take the derivative of both sides in terms of t. The derivative of omega in terms of t is going to be d omega dt. Derivative of 2t is going to be 2, and the derivative of t cubed is going to be 3t squared. We know that d omega over dt can be simply written as alpha, and so here we have our equation for alpha. And our final step is to plug in t is equal to 2 seconds again. We'll get alpha is equal to 2 plus 3 times 2 squared, which is going to be 2 plus 12, which will give us 14, and the units for this will be radians per second squared. I hope this helped, and make sure to tune in later for more physics tutorials.